Alright guys, we are live. Is anyone here? You can ask live math questions, and main topic I'll be covering is AI, but you can ask me anything you want. And is anyone here? We have 0 people in the chat. Let's go. But anyways, I'll just try to do some housekeeping. I'll try to get this thingy up. I'm actually running an AI thingy right now. We'll see if this works properly. Okay. Yeah, it tried to work, and then all of a sudden it stopped. Oh, Yin Gaza, let's go. From Austria, yeah. I was, let's see, you're the first person in the stream. I started doing this, like I said, I started doing this live stream in Wednesday mornings just to force myself to start looking at math stuff and just answering questions. I get a million math questions, like everywhere. I just don't have time to answer them, besides doing it live. But also, I do want to talk to you about those pink crystals, and also get you on the show maybe one day. All right. So we have another person in the chat, guys. Let me know. But right now we're going to be dealing with AI. But again, AI is just the main topic that I'm going to be covering, and it also helps me to research what stuff I want to research. But because I don't want to do it like on my own time, because I have a bunch of other stuff. So it's kind of like forcing myself to do it, but also getting live questions and answers. So how does AI work? I'm currently running this AI in video AI thingy right now. I'll read this out when there's more people inside. This is I'm making a alien scientist AI PSA public safety announcement about that Jeremy Reese disinfo agent. All right, I think we have some more people in the chat. Who's in the chat? Anyone else? I'll just say hi, Yin. And I also have I have a video. It's already launched on 3Speak. Because I can put all the bigger timestamps and so on. This is the John Hutchison interview with Elaine Smitha. It's another interview. So I'll be publishing this once I'm done this stream. I'll publish it on YouTube and so on. The reason I put it on this one first is because then I can add the full timestamps inside the Peak D setup here. So on Hive. So anyways, so move it on Hive. So I could put it in here, and I'll upload. So I'll add the bigger timestamps and so on, and fix this up soon. And also, this one takes a while to upload. So this one's already on there. And there's John. He also discusses how literally the Reagan Star Wars program, or the SDI, the Strategic Defense Initiative, literally classified the footage that they did for him, and then they wouldn't even let him see his own footage. And so on. So that's wild. And also similar with the Canadian government and so on. So this is epic stuff here. We'll play a tiny bit of this.
Well, for our viewers, we have all.
Yeah, and this is
Yeah. Yes, he's been a guest on the show.
Yeah, this one's on levitation and so on. So it's gonna be epic stuff there. Anyways, I'm gonna start researching AI. So again, I do this so I can research AI. I'm currently running an AI thingy. It's not working right now. I don't know what's going on here. Supposed to. I'll start it again. Anyways, I'm gonna copy and paste it. So I'm trying to make this AI video. I'm gonna copy this. This is a story. I'll read it out after because it's too ridiculous. I'm trying to make a funny but informative AI thing. Okay, so this is not working. I don't know what's going on here. I had it running, and then all of a sudden, oh, there it is. Public safety. This one had it running. Please wait while we load your creation. I literally had this. What is happening here? Okay. So it's loading. Okay, there it is. Loading preview. Okay, there it is. It did work. So 1 minute long. Let's play this right here. We'll play this. So for those in the chat, this is Jeremy Reese, alien scientist, disinfo agent. Let's play this.
I'm sure you've heard the news. Jeremy Reese, or alien scientist, is not who he claims to be.
Well, I'm gonna just download with watermark, stock watermarks, AI branding, normal resolution. Okay, 1080p. Yeah, we'll do 1080p. I'm gonna download this because it wasn't working before. You're number 2 in line. Oh, good evening, inmates. Oh yeah, that's life. I saw your memes about about the alien scientist. I have one right now I made. We're gonna play it first time ever. I'll share it later. And here's the text of it. So basically, I asked AI in video this in video program. I said, make a public safety announcement about a video about make a public safety announcement video about a man named Jeremy Reese that goes by the online username Alien Scientist. He allegedly chased his then girlfriend with a machete 10 years ago, and is now allegedly, I don't want to get sued, accused of beating his then wife. I'm gonna move this over. Okay, let's go to Jeremy. Oh, I have it. I have a folder here with a bunch of. Let's go to disinfo agents. Let's see. Where's the disinfo agents? Disinfo agents. So Jeremy Reese is in there. So yes, I am very structured, even in my takedown of these disinfo agents. I'm gonna move this over, and I'm gonna just put this there. I'm gonna paste this paste bin inside, and also this in video. It's loading up. Okay, there it is. It's live, and I downloaded it. So let's play this one. I'll I'll read this one after and let's see what it says. First time, I haven't even seen it all yet. This is the first time ever. Let's watch it.
I'm sure you've heard the news. Jeremy Reese, or alien scientist, is not who he claims to be. Here's why you should be concerned. Jeremy Reese has a troubling history. Allegedly, he chased his then-girlfriend with a machete in 2015, and more recently he's been accused of beating his then-wife and is currently in a custody battle, but it doesn't stop there. Jeremy Reese spreads dangerous lies about 9/11s, pushing the thermite theory to cover up the use of directed free energy technology. This disinformation campaign raises serious concerns. Some even speculate that intelligence agencies may be recruiting criminals like Reese for their deceptive agendas. Your safety and the truth are at stake. Always critically evaluate the information you come across. Stay informed, stay safe. Beware of Jeremy Reese and his dangerous lies.
Alright, let's go, guys. And how's my audio? How's the video audio? And so on. Alright, this is epic stuff here. I'll share this and I'll share it later. Okay, I'll do it right now. I'm gonna share this AI. Okay. Yeah. Anyways, so this was requested by 9/11 revisionist. I said might make one of his court case about beating his wife, and I'll send the whole video. And I'll say PSA. Okay. Okay. So we sent that one, and let's see what happens. And now I'm gonna go back into how AI works. If you guys have audio is good, okay, perfect stuff. And sounds good, guys. Let me know how the audio. Actually, I want to test out. I'm on Rumble as well, guys. Because someone said that they didn't like chat in the YouTube. I'm gonna see if this works. You guys have the audio is good. We'll do 1080p. I'm gonna download this. Okay, so this is good, and I have the chat here. So if anyone is in Rumble. So anyways, this was going to be a quick live stream. I'm going to finish at 2 as always. And what I'll do is... One second. Okay, yeah, and also here's on Threadcast as well, guys. If you go post on in Leo Threadcast, asking questions and so on, I'll upvote your stuff and you get cryptocurrency for that. And anyways, sign up for it. Alright, and okay, there's the... William Anderson, there's the live stream link. Let's go. You put it on the... thanks That's Life for sharing the link in the group. Alright, anyways, so there's also a global technocracy. This is a pretty good one on that Richard Hall made on CBDCs and other stuff like that. That was the latest one. But what I want to go over, and also that AI video, here's what I asked it. So I literally just went to the AI in video, and I asked it this question. Make a, let's see, I said, make a public safety announcement about a video about a man named Jeremy Reese that goes by the online username Alien Scientist. He allegedly chased his then girlfriend with a machete 10 years ago and is now allegedly accused of beating his then wife, whom are currently in a custody battle for their children. Jeremy also purposely pushes disinformation and misinformation about the events of 9/11 by pushing the obvious thermite lies in order to cover up the use of directed free energy technology on 9/11. And this raises concerns that intelligence agencies are hiring criminals because they're easier to control and more willing to deceive the public. All right. Anyways, guys, let's continue in our journey. I'm gonna close these stuff. I'm gonna go into. I have a folder of links there, and I'm gonna do some testing with DeepSeek and so on. But what I want to look at. So this is DeepSeek stuff. Okay. Let's see. Okay, and Natalie asked me when am I gonna post that video. Okay, so I'm in the stream right now as we are going live. Okay, oh, the AI summaries worked. Interesting. What is this AI summaries for? Okay. Oh, this thing worked. Okay, this is amazing. It's absolutely amazing stuff here. Okay, so I'm literally using an AI bot agent on the Hive blockchain to summarize a full live stream right here. This was a live stream, 4-hour live stream of City of Coral Gables, where the Jackson Rip Holmes actually spoke out and shared one of my videos of the Hutchinson effect, and so on. And then I asked him to summarize here. Let's see if Holmes. This is DARPA. See, DARPA shows up. Yeah. Okay. This is major in there. Future growth. Is there Holmes? Did he make it in here? Technology or energy. Energy. Where's the word? Oh, that's energy there. Anyways, this is just summarize the full. Yeah, you could literally just summarize the full 4-hour live stream. It uses the transcript and it just summarizes it all into stuff right here. Anyways, and then you see Jackson Rip Holmes right after.
Going on with City Hall. When I was driving today, I saw a construction company.
So there's.
Greetings. Thank you all so much. I've learned a lesson here. The people at home are on that camera and news.
Okay, anyways.
Are you surprised to hear yourself saying this? Very much.
This is DARPA admitting cold fusion is real, and anyways, and then he also shared the next one, the floating mill ball, but anyways, a cannonball for what everybody thinks is cannonball. Even John Hutchinson, he never corrected the newscasters when they said it. How does AI work? Black magic, of course. We'll get to the AI stuff soon. I'm gonna go.
My friend. John.
And I don't know why there's a huge weird background noise in the background. But anyways, he shared a video, epic stuff, right in front of the city hall, and he shared several of my Hutchinson effect stuff. All right, I'm gonna continue further now. So what I wanted to go into the this one here, I want to say because it's pretty much the most popular one. Neural networks. How it works. We're gonna do some. I'm gonna go deep dive into it for as long as we have. Yeah, this is a really good video. It's basically it's just calculus and derivatives, but a million times, and adjusting numbers to fit the results you want. All right, so we're gonna go over here. Three blue, one blue. But what is a neural network deep learning chapter 1? So this would be epic stuff. Let's see the full playlist. For those, let's see the full playlist. Learning to see neural networks. Where's this full playlist? Does he have one? I'm gonna go over it and then any questions. But yes, black magic's pretty much it. But again, the thing is, it's similar to computers. Computers is just like a bunch of ones and zeros, and then like from there you have the human creativity and just make infinite ones and zeros. Similar to this one, it's just basically derivatives. And then take it a million times over. It's kind of like language. Language, you have like 26 letters, but now you can make anything you want out of it. So that's the thing with even AI. It's just basic, simple stuff. We'll play. I'm gonna play some of this because it's been a while since I've seen it. It's literally saw it like years ago, but I thought it was really well done. I was gonna eventually do some AI math videos, but I want to see if he has a playlist on this, so I could. Let's go to playlist. Let's go to optical. I think he had one. Neural networks. Okay. Okay. It doesn't look like he has neural networks. I'll just write neural networks. Okay, neural networks. Okay, he has a full course. Okay, yeah, it's a course. That's interesting. Okay, so yeah, there's the course. This is good stuff. There's a whole bunch I haven't seen. How LLM store facts and so on. Okay, so we're gonna go literally in here. I'm gonna save this video. Yeah, this is a good thing I saved it. And also before we go further,
hey, internet friend.
This was Operation Stargate. Let's say Stargate Trump Wiki. Oh, actually, this is the video right here. I'm gonna do this right now. I'm gonna go right here. So you can go on the let's go to InLeo. So I have that summary video. And this is Project Stargate that Trump's launching basically $500 billion to fund AI infrastructure and so on. So in other words, they're going to print $500 million worth. So they're going to devalue the currency in hopes that AI will be more productive. Okay, so this is the threadcast right here. I'm gonna put it right here actually. Where can I put it? I don't want to get above. Okay, I'll just put it right here. I'm gonna go Actually, I'll put it separately. So that I'm going to go to a new one. So I'm going to keep the threadcast open. If there's any questions there, so far 0. But if anyone does show up, you get an upvote. You get like 20 cents or whatever. Way better than whatever this YouTube is. I'm going to summarize this using an AI agent to summarize this video by really graceful there. And it should show up some. This is previous summaries, and then just so it's easier to see. Anyways, so that is that, and then also Stargate, Wiki, Trump, and it's interesting they call it Stargate. That's yeah. So this one here, the Stargate project. Yeah, and it was named after an interesting name. If the U.S. prints even more money, it's likely going to result in a complete collapse of the economy. And not really. Well, it's printing it, but it's like the way it's designed is that it's printing it, but hopefully that the productivity is more. So it's like, but it's not going to be, obviously not going to be more. So the currency is going to get slowly devalued, and so on. So it's like right now what's happening is what's happening forever. It's a slow quote collapse. It's not a. It's like a gradual decline over just over years. Over decades. So you're not going to have a sudden collapse, in my opinion. And that's what World War III is there to clean up. So when you have World War III, it's kind of like, okay, we're going to do it. It's similar to COVID. Everybody thinks it's going to all collapse. Now you have COVID, you shut down everything. Everything becomes stagnant and so on. And then now you have to print more money to fix that PSYOP up and so on. So it's like, it is, but it's also like publicly you'll see it's going to be the same thing as always. Just gradual money printing. Anyways, so the Stargate project, interesting name. So it's American intelligence joint venture founded in January 2015. This one is incorporated in Delaware, and it's a venture created by OpenAI, SoftBank. This is ChatGPT one, Oracle. Oracle's a big CIA one, and so on. And investing up to $500 billion as from Trump campaign, and so on. But then the previous name they used was Stargate project. This is on that remote viewing stuff. Stargate right here, you go to the remote viewing or the little teleportation by your mind. Stargate project work primarily involved remote viewing. And now all of a sudden we're going with AI stuff. So AI remote viewing. Anyways, so there can be a whole bunch of money being spent on AI. So let's just dive right into the neural networks playlist right here. I'll do it like this instead. Yes, this is a course. Interesting. So I'm gonna go and play. And then whatever is obvious, I'll fast forward and let me know if you have questions. Oh, but and also if you have any math questions and so on. This is what I use this 2 hours. You have 2 hours to ask me anything.
This is a 3. It's sloppily written and rendered at an extremely low resolution of 28 by 28 pixels, but your brain has no trouble recognizing it as a 3. And I want you to take a moment to appreciate how crazy it is that brains can do this so effortlessly.
Okay, Tim Spiker says China's been doing the same, but from what I understand, they're putting it in massive battlefields. Battle fleets, so World War III might as well be the plan. AI is being put in everything. Like, I have, like, Microsoft Windows, and there's, like, Copilot in here. If I just go on, like, even my notepad and so on, this is the Hudson effect stuff right here. If I anywhere I type, anywhere I put my thingy, there's a Copilot thingy here. So it's like anywhere you go, there'll be AI infused everywhere. So you can summarize page, you could rewrite page. So for example, so what I mean is, it's not just going to be in like military. It's going to be in literally everything because it's like automation. So now you can literally automate cognition or intelligence and so on. So if you go to Microsoft Word, they already have it just built in randomly just with an update and so on. So you can literally, it has it built in with Copilot. They made it free now in part of the thingy, or part of my Office 365. But anyways, so you have Copilot built in. Then you can select the icon or press Alt to draft with Copilot. So you can, let's go to draft, and you can describe anything. Give me, or prepare some notes for an AI mathematics live stream right now that I need to do. Oh yeah, okay. Tim Spiker says it means the money, not the AI. Probably AI as well, but the money manually. And that's the thing with AI, because the whole idea is if you print money, but if you have productivity and then there's a whole bunch of demand for AI agents. So because every AI agent's going to need money to do stuff. It's not going to be just all free like this, neat and dandy. Eventually it's going to be like, because someone's paying the cost behind the scenes. And so like ChatGPT and so on, OpenAI, they're getting a whole bunch of funding in hopes that eventually they'll turn in a profit. So the whole idea is all of this is going to require money. So even if you, let's say, double the money supply, but if you've 10x the AI agents and all that, and they all need micropayments. So you're going to have a whole bunch of anyway. So here I just drafted it. You're going to have that money flowing into it. So it's kind of like so I think AI will help literally make the economy much bigger. So we'll be talking in trillions and so on. So you'll have a lot of big companies also get into like multi-trillion, like double-digit trillion market caps and so on, and so forth. Anyways, so here I just made it. This literally has it infused inside, but the big thing is I think it's going to be so notes for AI live stream. Provide links to relevant articles, summarize the key points. Anyways, it's just like it's like ridiculous. I need an AI to like summarize what this AI has just said to me. All right. But yes, so basically the whole idea is productivity just means getting that money throwing it somewhere. And this is eventually what's going to happen is AI and crypto are going to merge together, because getting an AI agent to spend, like, let's say a credit card, it's not that easy, and a lot of the payments aren't settled right away. They're not settled instantly. They take like a whole day or 5 days. So with AI, you need like typically you'll need instant settlement if you're dealing like with 0.01 cents. You're not going to have like a review of like a million different transactions. So it's like all going to be on blockchain. Like the payments will be on blockchain and so on. And there's going to be a whole bunch of need for just money to use all these stuff. Because like for example, this one here. Let's go to the summary. I did the summary right here to summarize this. So I'm paying $5 a month for this AI agent, and it just summarized all right now. So oldest, but this requires some computing power, and with Hive, the transactions are free, but you need to stake your Hive to get more. So the more you stake, the more you could post. Otherwise, you have to wait a lot. So they have a lot of Hive staked in here. And that costs money. So in other words, productivity increase. So as long as productivity goes up, you can lower the money, devalue it, and so on, because there'll be demand for it. Okay, so anyways, the worst is when there's no demand for money. When there's literally no productivity going on. Anyways, so this reflections on this concerning paradigm shift, alluding to the overarching. Oh, this is part 9. Addressing rising cancer rates and a consistent introduction of known carcinogens in the marketplace is just a troubling narrative. Anyways, yeah, the other thing is the Stargate one. Go back to Stargate wiki. Stargate project. Where's that? Oh no, that was the army unit. Let's go back to other Stargate. I think there can be a whole lot of a lot of this is going to like cancer. I think cancer stuff. So they're developing AI facilitated production of mRNA vaccines against cancer and so on. So they're going to basically use AI to have specialized everything, specialized medicine or mainstream medicine, and you get vaccinated everywhere, and they'll check your blood for random quote cancers and so on. In other words, again, when you're printing $500 billion, but now let's say you're printing it, but now you're also getting a whole bunch of AI agents and AI just software in everything. So before you would, let's say, go to a hospital or do a checkup, now they're going to have to use a whole bunch of different AI stuff. And in other words, they're going to use a whole bunch of computational power, and that requires money and so on for pretty much everything. So you're going to have personalized giant databases on every single human and personalized vaccines and other stuff like personalized NWO stuff like that. Anyways, it's becoming like China. And so anyways, go back to this. I'm going to go, what else? We're going to go right here. First part, what is a neural network? So this helps you. This video was the only one I've seen. I didn't see the other ones. Or actually, maybe I've seen a bit of the other ones. But the whole idea is, actually, I've seen some of them, but not all. The whole idea is like, how do you get, so like right now, when you look at the number 3, and it's all pixelated, but we know it's a number 3. This is number 3. But the thing is, how do you get a computer to know that's number 3? And this explains in a very basic way how AI networks work on this, or neural networks, and basically how your brain works. I'm going to play this right here.
I mean, this, and this are also recognizable as 3s, even though the specific values of each pixel is very different from one image to the next. The particular light-sensitive cells in your eye that are firing when you see this 3 are very different from the ones firing when you see this 3. But something in that crazy smart visual cortex of yours resolves these as representing the same idea, while at the same time recognizing other images as their own distinct ideas. But if I told you, hey...
Yeah, basically, yeah, the whole idea is like, how does your brain know it's a 3 even though it's all messed up? And this one's not a 3. It looks like a 5. So the thing is, how does your brain work?
Write for me a program that takes in a grid of 28 by 28 pixels like this and outputs a single number between...
Yeah, okay, so this is basically a neural network. So you have the... let's go back and forth. Oh, well, I hit where you can't do... When I press it, it just goes down.
A grid...
Yeah, so...
but if I told you, hey, sit down and write for me a program...
Yeah, so let's say you have a number 3 right here. And then the whole idea of neural networks is you'll take this image, and then you assign values to what... Yeah, basically assign values and somehow get that to number 3. So in this case, you're going to assign all the non-3... Yes, basically assign numbers to how close they are to a number 3. So at number 3, it looks like this. Everything around it, those are all, we'll call that all 0. You're not going to have a value here if you have an image of a number 3. All around it should be 0.
Program that takes in a grid of 28 by 28 pixels.
So in this case, all the black color, they'll make it a 0, and then all the whites, they'll just put it at 1 right now. And then anything that's like grayish, they'll put it in a fraction between a 0 and 1. So that's
like this, and outputs a single number between 0 and 10. Telling you what it thinks the digit is? Well, the task goes from comically trivial to dauntingly difficult. Unless you've been living under a rock, I think I hardly need to motivate the relevance and importance of machine learning and neural networks to the present and to the future. But what I want to do here is show you what a neural network actually is, assuming no background, and to help visualize what it's doing. Not as a buzzword, but as a piece of math.
And yeah, we'll get to the actual nitty-gritty math of it. It's just like matrix algebra and a bunch of derivatives.
It's just that you come away feeling like the structure itself is motivated, and to feel like you know what it means when you read or you hear about a neural network, quote-unquote, learning. This video is just going to be devoted to the structure component of that, and the following one is going to tackle learning. What we're going to do is put together a neural network that can learn to recognize handwritten digits. And
this is typically the one that they teach when you learn AI. I haven't learned it. I haven't gone through the full book, but when you go through textbooks, typically the main one is like how do you get a computer to recognize a hand-drawn text, like hand-drawn images as numbers. So this is number 7, and then there's a whole bunch of stuff right here, calculations, and it gets to number 7.
This is a somewhat classic example for introducing the topic. And I'm happy to stick with the status quo here, because at the end of the 2 videos, I want to point you to a couple good resources where you can learn more.
So I'm going to open this up and put it sideways right here. Okay, go back to the threadcast. Alright. I'm going to go back. Okay, this was not the threadcast. This is the threadcast. I'll just have it open on the side so that if anybody signs up for Hive and yeah, you get again like I have to like say that a million times. When you post, you get some crypto, and your comments are always there. You don't need to worry about me censoring them and so on. I could like hide you from there, but your comments will never be gone like YouTube. I have no idea what YouTube is doing half time. Anyways, all right. So I'm gonna go back to this.
And where you can download the code that does this and play with it on your own computer.
Interesting. I may have to download that code there. But anyways, let's play this.
Many variants of neural networks, and in recent years, there's been sort of a boom in research towards these variants.
Okay. Yeah. So this one here, then you're gonna have different ones for other stuff. But let's play this right here.
Form with no added frills, and trust me, it can learn. At the same time, which is a pretty cool thing for a computer.
So here's when you put in 9, it gets a 9, and so on.
Of a couple hopes inspired by the brain. Right now, when I say neuron, all I want you to think about is a thing that holds a number, specifically a number between 0 and 1. It's really not more than that. For example, the network starts with a bunch of neurons corresponding to each of the 28 times 28 pixels of the input image, which is 784 neurons in total.
Okay, yeah, so again, it's viewing it as a human brain, so everything's a neuron right here, and a neuron holds a number. All right. So in this case, for determining a number, you have lighted basically the written region, and then the non-written, the zeros.
Each one of these holds a number that represents the grayscale value of the corresponding pixel, ranging from 0 for black pixels up to 1 for white pixels. This number inside the neuron is called its activation. And the image you might have in mind here is that each neuron is lit up when its activation is a high number. So all of these 784 neurons make up the first layer of our network. Now jumping over to the last layer, this has 10 neurons, each representing one of the digits. The activation in these neurons, again, some number that's between 0 and 1, represents how much the system thinks that a given image corresponds with a given digit. There's also a couple layers in between, called the hidden layers, which, for the time being, should just be a giant question mark for how on earth this process of recognizing digits is going to be handled. In this network, I chose 2 hidden layers, each one with 16 neurons, and admittedly, that's kind of an arbitrary choice. To be honest, I chose 2 layers based on how I want to motivate the structure in just a moment. And 16? Well, that was just a nice number to fit on the screen. In practice, there is a lot of room for experiment with a specific structure here. The way the network operates, activations in one layer determine the activations of the next layer. And of course, the heart of the network, as an information processing mechanism, comes down to exactly how those activations from one layer bring about activations in the next layer. It's meant to be loosely analogous to how in biological networks of neurons, some groups of neurons firing cause certain others to fire. Now the network I'm showing here has already been trained to recognize digits, and let me show you what I mean by that. It means if you feed in an image, lighting up all 784 neurons of the input layer according to the brightness of each pixel in the image, that pattern of activations causes some very specific pattern in the next layer, which causes some pattern in the one after it, which finally gives some pattern in the output layer. And the brightest neuron of that output layer is the network's choice, so to speak, for what digit this image represents.
Alright, yeah. So yeah, you guys still following along. But basically, you got a bunch of stuff in the middle. You go from the, you take all the pixels, assign a number based on the color for this specific case, and then you have some hidden layers, we'll get to that in a bit, and then somehow it points towards which is the most likely one. Cloud Server 69, yo, what is happening? Again, guys, feel free to ask any questions, but like I do, basically Wednesdays, 10 a.m., I just jump in for 2 hours, and anyone has any questions, math-related, science-related, I'll try to answer. But then also try to get a specific topic here. Hello, everyone. Hope you are all okay. Yeah, for sure. Cloud Surface 69. Let's go. And the current one, if there's no questions, I just go to the topic that I want to discuss or just research more. AI right now.
And before jumping into the math for how one layer influences the next, or how training works, let's just talk about why it's even reasonable to expect a layered structure like this to behave intelligently. What are we expecting here? What is the best hope for what those middle layers might be doing? Well, when you or I recognize digits, we piece together various components. A 9 has a loop up top and a line on the right. An 8 also has a loop up top, but it's paired with another loop down low. A 4 basically breaks down into 3 specific lines and things like that. Now in a perfect world, we might hope that each neuron in the second to last layer corresponds with one of these subcomponents. That anytime you feed in an image with, say, a loop up top, like a 9 or an 8, there's some specific neuron whose activation is going to be close to 1. And I don't mean this specific loop of pixels. The hope would be that any generally loopy pattern towards the top sets off this neuron. That way, going from the third layer to the last one just requires learning which combination of subcomponents corresponds to which digits.
Yeah, so this is a good way to view it as well. So the hidden layer is basically takes that image and then separates up into different parts that make up, for example, each number. So the 9 right here, 9 has a circle and a downwards line, and basically the images that most correspond to that would match up with it. So in other words, if you have this neuron and this one here, the 0 and this one, those ones are firing. In other words, this image contains that. Then this goes to over here. Then that goes to number 9.
Of course, that just kicks the problem down the road, because how would you recognize these subcomponents, or even learn what the right subcomponents should be? And I still haven't even talked about how one layer influences the next, but run with me on this one for a moment. Recognizing a loop can also break down into subproblems. One reasonable way to do this would be to first recognize the various little edges that make it up. Similarly, a long line, like the kind you might see in the digits 1 or 4 or 7, well, that's really just a long edge, or maybe you think of it as a certain pattern of several smaller edges. So maybe our hope is that each neuron in the second layer of the network corresponds with the various relevant little edges. Maybe when an image like this one comes in, it lights up all of the neurons associated with around 8 to 10 specific little edges, which in turn lights up the neurons associated with the upper loop and a long vertical line, and those light up the neuron associated with a 9.
Alright, yeah. So it looks like, so the first hidden layer in this case would be just separate everything into little parts. So if you just get them to recognize small amount of parts, and then if those ones are adjacent to each other, like for example this line, you have 1, 2, and 3, those would fire these, this neuron right here. And if you have a circle one of these line up in a circular pattern, this fires over here. So basically, this is a pretty interesting one. Yeah. So somehow get this to recognize small parts, and then put those together in this one, and then put the combination over here. So that's pretty epic stuff.
Whether or not this is what our final network actually does is another question, one that I'll come back to once we see how to train the network. But this is a hope that we might have, a sort of goal with the layered structure like this. Moreover, you can imagine how being able to detect edges and patterns like this would be really useful for other image recognition tasks. And even beyond image recognition, there are all sorts of intelligent things you might want to do that break down into layers of abstraction. Parsing speech, for example, involves taking raw audio and picking out distinct sounds, which combine to make certain syllables, which combine to form words, which combine to make up phrases and more abstract thoughts, etc. But getting back to how any of this...
it's going back over to here. So you have a recognition separated out into each syllable, or I mean each pronunciation or whatever. I think that's what's called syllable. No, recognition. Yeah. So and then this one combine it together, and you'll have two different types of words that could change. So recognition, or you can have a cognition by itself. You could put this re into a whole bunch of other stuff like that, like repeated, redo, and so on. So this, and also what these are called in AI, this is like each of these specific thingies here are called a token. So that's another thing. I'll keep that in mind for future.
Got phrases
and also when you hear about let's say ChatGPT and so on doing having database of like millions of tokens, that's what they're discussing right there.
More abstract thoughts, etc. But getting back to how any of this actually works, picture yourself right now designing how exactly the activations in one layer might determine the activations in the next. The goal is to have some mechanism that could conceivably combine pixels into edges, or edges into patterns, or patterns into digits. And to zoom in on one very specific example, let's say the hope is for one particular neuron in the second layer to pick up on whether or not the image has an edge in this region here. The question at hand is, what parameters should the network have? What dials and knobs should you be able to tweak so that it's expressive enough to potentially capture this pattern, or any other pixel pattern, or the pattern that several edges can make a loop, and other such things? Well, what we'll do is assign a weight to each one of the connections between our neuron and the neurons from the first layer. These weights are just numbers. Then, take all of those activations from the first layer and compute their weighted sum according to these weights. I find it helpful to think of these weights as being organized into a little grid of their own, and I'm going to use green pixels to indicate positive weights and red pixels to indicate negative weights, where the brightness of that pixel is some loose depiction of the weight's value. Now, if we made the weights associated with almost all of the pixels 0, except for some positive weights in this region that we care about, then taking the weighted sum of all the pixel values really just amounts to adding up the values of the pixel just in the region that we care about.
All right, let's go back to here. So basically you have, these are the numbers of the lit pixels up, and then these are the weights you're assigning, and then you multiply them together to get a weighted sum. So and what they're doing in this case is So you want that specific region. This one here, you want the specific region right here. So anything in that region, you'll give a higher value for the weight, and then everything not in there will be 0. So then this one is basically in a weighted sum. The only one that will fire will be only in this region, and that's lit up by this part right here.
Really just amounts to adding up the values of the pixel just in the region that we care about.
Because everything else will be 0. So if this is a 0 times whatever, then even if you have something lit up here, like this part here is lit up. This is, let's say the number here is 1. This is 1. But the weight is here is 0, because you only care about this edge right here. So then this weighted sum will be 0 on all around it.
And if you really wanted to pick up on whether there's an edge here, what you might do is have some negative weights associated with the surrounding pixels. Then the sum is largest when those middle pixels are bright, but the surrounding pixels are darker.
Okay, interesting. So now you have a negative weight as well around this one. So as opposed to just 0 there, you have a negative weight so that you'll know that the edge will be around this part there. Interesting. Let's see how that works.
When you compute a weighted sum like this, you might come out with any number. But for this network, what we want is for activations to be some value between 0 and 1. So a common thing to do is to pump this weighted sum into some function that squishes the real number line into the range between 0 and 1. And a common function that does this is called the sigmoid function, also known as a logistic curve. Basically, very negative inputs end up close to 0, very positive inputs end up close to 1, and it just steadily increases around the input 0.
Oh yeah, anyway, so this is just a function right here where you could put in any number. So if you have 1 here, if you put 10 here, put it over here, and this is going to be between 0 and 1. So that's the whole idea, is put it between 0 and 1 just for the calculation of 1. And this one, it's pretty straightforward. You could convert any number into any kind of scale that you want, and so on. So this is 1 plus, I'm going to put the Excel file right here. Let's pull this out right here. Just to illustrate. That this is pretty standard stuff. I'm gonna save this. So I'll save it after. The whole idea is, let's say if you have a number 10. Let's say you have 10, and then you want to then let's just see what the number is. The sigmoid equals 1 divided by 1 plus e to the power of this one here. I think it's negative. E to the negative. E to the negative, missing a parentheses. Okay, this is, I don't know why it's saying name. Oh no, exponent, my bad. Exponent. Okay, so 0.999. So if we put a 10 there, it goes to that. Put in a 2 and a negative 10, and this is roughly 0. I'll just make it number. Yeah, so it's roughly that. Anyways, so the whole idea is just put in that random thing here. 24 would be pretty much 1. Anyways, all right, let's continue further.
So the activation of the neuron here is basically a measure of how positive the relevant weighted sum is. But maybe it's not that you want the neuron to light up when the weighted sum is bigger than 0. Maybe you only want it to be active when the sum is bigger than, say, 10. That is, you want some bias for it to be inactive. What we'll do then is just add in some other number, like negative 10, to this weighted sum.
All right, okay. I think I understand this. The part where it has the edge, where these negative values there, is that because if you only want it here, but if you have something that goes past it, that means there's no edge. So that's a really big negative. So you need to have something with an edge here. So a straight line like here. You can't have something past this and then because if these are all lit and this one isn't, and this one, I mean, if this is all lit and this one, then you're concerned with the edge. So there's no edge. So get rid of that. So that'll be a negative there, as opposed to if it was as opposed to if you didn't have anything there, there's more likelihood having an edge there. Anyways. And also here's activation, meaning only when weighted sum is greater than 10. So this one here, greater than 10, basically says that this weighted sum of this whole thingy, it has to be high enough that you're confident it's going to be a straight edge. You can't just have like let's say 1 or 2 of them here, and that'll be not good enough. Let's say you have a score of like of 2 or something like that, and that's not good enough for an edge. And you need to be very high, in this case 10.
For plugging it through.
So you just put a minus. How positive is this? Yeah, so you put a minus 10 like that. So you subtract it so that anything else would just be negative there. Weight sign greater than 10.
Through the sigmoid squishification.
Because this thing just gives you between 0 and 1. So you're always going to have it above 0. But now you need it to be above 10. So you minus the 10. So the only way for it to be positive is if this whole thing is greater than 10.
Function. That additional number is called the bias. So the weights tell you what pixel pattern this neuron in the second layer is picking up on, and the bias tells you how high the weighted sum needs to be before the neuron starts getting meaningfully active.
All right, Rumble has our first chat here. St. David's, bless up Matt and chat. Let's go. Let's go, St. David's. All right, we have our first Rumble chat in there. And also, guys, no one's on in Leo.
And that is just one.
Make sure to go down in Leo Threadcast, and you can post and get earn crypto live. Let's see if I can make this just bigger. Okay, and yeah, and if you post it here, we'll be all showing it right there live, and we can basically, upvote yourself and you get crypto. Anyways, let's continue further. And again, if anyone has questions, math stuff, let me know and in the chat, and I'm gonna continue further with this.
One neuron. Every other neuron in this layer is going to be connected to all 784 pixel neurons from the first layer. And each one of those 784 connections has its own weight associated with it.
Oh yeah. So basically, this is the first hidden layer in a neural network. So this one again, summarize. This one is the this is the images. I mean, this is the amount that's lit up. I'm on YouTube at the office. Tammy, let's go. Yeah, no worries, Tammy. Yeah, I made an account for you, Tammy. Did you see the account on Inleo? Let's go to, I made that account for you. I don't know if you got the email or not, but I did. If you go to threads, I said right here, okay, welcome, Mario. Yeah, this one here, welcome to Inleo/Hive Painters, and I got 22 cents. Basically half that is mine, so 11 cents I made just by tweeting at you. So 11 cents USD, that's absolutely unheard of, just by tweeting this. So that's your account. Your account's made. You don't need to buy any crypto, it's already there. You have 1 follower, it's made. So anyways, sign up, you get MES follows you. Sounds good. Let's play this for this. Going back here, so these specific weights, so these ones right here are a number between 0 and 1. I did not see it. Interesting. So I sent you an email. I don't know why I did not see it. It might have gone to your spam. I don't know. Let's go to. Okay. I sent it to your Yahoo one. The Yahoo email. I'll send it to the other one as well. Forward. No, I mean you should have it. I did reply to you. I'll show you to you right here. Here's the email. Yeah, Tammy, thanks. I am the best. Let's go. Just think about heart-shaped energy forces. Let's go, Jeff Stewart. Yeah, and if you guys have any questions, let me know. Again, this is I use the AI one as just the main topic. Not a main one, just a default one. If there's no other questions. So here, Tammy, here's the email I sent you. So just check it out. I put in. So I made your account, and I also delegated you some resource credits. I'll remove them once you have enough hive power and so on. Because I'm working with remote and it's rural. Interesting. So and these are apps that eSense one you can download it as a phone app. Otherwise, it's pretty good on the phone. But then also in Leo you could use it as X and Peaked. I like it for just long posts, but you could do that with all of these, and you could even do the short posts with all of them as well. And the Hive keychain, just download that, put the keys in there, put the master password in this one, and and you can change it if you don't want me access to it later on in the future, and so on. Let's continue in our journey. All right. Okay, so anyways, going back to this neural networks right here. So this first layer right here is just the amount that's being lit up. So 1 is being the pixel is lit up, or 1 meaning just it's white, 0 is black, and then you have a gradient in between. And then these next ones are these are the manually the specific neurons you're adding for each edge or yes, for each little part that you want to assign, for each little part that is like makes up a part of a number, and then you want to put that for every single part that you're interested in it. So for example, that edge part right here, let's go back here. Let's go.
Also,
So back, for example, the other one here, you added this edge here. So this whole neural network here, just put this edge, and the weights are assigned just around it here. So you have negatives around it, so that anything goes by it. You don't want that at all because you only want an edge. So for example, if this curved part was in it, that would not be good. But anyway, so you assign this part you assign this part or you specify this part here what gets a value. So these ones all get 1 1 1. This gets negative, and in the center we'll probably have a bigger number. Everything else gets a 0. Then you compress it with a sigmoid function in between between 0 and 1, and you also assign a weight so that you need at least the weighted sum of 10. Anyways, or a bias in that setup there. Okay, Tammy, I'm great with it. Matt, I will be back home in 2 days. I'm excited to use Leo. Yeah, for sure. And use that for the threadcast and too. And then again, you'll learn crypto, and it's your data. That's the thing. The key part is it's your account. So this stuff is your account in Leo. Your posts are your posts. No one can take that from you. YouTube can't remove it. I can't remove it. I can't do anything about it. And so it's like right now, YouTube, this YouTube live stream, these chats, you don't own any of this chats. These are all YouTube's, and they can remove it and delete it and even change it. They can even make you change what you actually said and so on. And the other one, no one can do it unless you have the private keys. All right, let's continue further.
just one neuron. Every other neuron in this layer is going to be connected to all 784 pixel neurons from the first layer. And each one of those 784 connections has its own weight associated with it. Also, each one has some bias, some other number that you add on to the weighted sum before squishing it with the sigmoid. And that's a lot to think about.
And the bias stuff could be thought of as like how important each of these neurons are. If it's like just a small section that all the numbers have, then you can have the bias less. If or more depending on your scenario. Or if it's one that is if it's one that nobody has, you could put it as if it's one that all of them have, you don't need to put a bias. But if it's one that only one has, you need to have a specific high bias so that nothing else gets fired. Okay, Tammy, thanks for your learning for sure.
With this hidden layer of 16 neurons, that's a total of 784 times 16 weights, along with 16 biases. And all of that is just the connections from the first layer to the second. The connections...
Yeah, okay, so keep that in mind. So this one here has 16 weights, or 16 different small pieces of, or small sections of a number. And these ones are all the pixels. These are the pixels. Now you have them in slightly bigger parts that you want that you want a weighted number to assign. And then you also have the biases for every single one of these. So you have a whole bunch of data points right here.
Layer to the second. The connections between the other layers also have a bunch of weights and biases associated with them.
And then, yes, that's the first layer. And then the next one, you could have an even bigger abstraction. So now you could add combinations of these two that form a bigger part of a number. And then these all have biases as well. So you're going to have 7, 8, 4. And then each of these are going to multiply by every single one. So this one multiplied by this, multiplied by this, multiplied by this, and so on. So in other words, you're going to do 7, 8, 4 times 16 plus weights are 16. And then you have why is there another 16 right here? And go back to this part right here. Why is it 7, 8, 4 plus 16? Oh yeah, then you have 16 times it by 16 weights. Yeah, let's go back here.
The connections between the other layers also have a bunch of weights and biases associated with them.
Actually, no, these are weights. Oh yeah, never mind. Yeah, so this is 784 times 16. And now you have another 16 right here times 16. So 16 times 16. Because this one here times by the first weight. Then you have times by the second one, and it's all the way to 16, and then you do the same thing for this one here. This one times by this one times by this. So you have a whole bunch of data points here. And then last one, you have 16 right here, times it by all of these, then it times it by all of these weights. These lines are all weights. And then you also have 16 plus 10 biases.
All said and done, this network has almost exactly 13,000 total weights and biases.
Yeah, so 13,000 weights and biases just to predict just to analyze a number or to see it, to recognize a number.
14,000 knobs and dials that can be tweaked and turned to make this network behave in different ways. So when we talk about learning, what that's referring to is getting the computer to find a valid setting for all of these many, many numbers so that it'll actually solve the problem at hand.
Yeah, so learning is just getting all those numbers, and then so somehow it can analyze the number correctly, or just know the number.
One thought experiment that is at once fun and kind of horrifying is to imagine sitting down and setting all of these weights and biases by hand, purposefully tweaking the numbers so that the second layer picks up on edges, the third layer picks up on patterns, etc. I personally find this satisfying rather than just treating the network as a total black box, because when the network doesn't perform the way you anticipate, if you've built up a little bit of a relationship with what those weights and biases actually mean.
Yeah, so you can do this manually a million times and then see why, what number is it finally giving out. Like this one here is 0, that's wrong. You have to adjust the weights and biases and so on.
You have a starting place for experimenting with how to change the structure to improve. Or when the network does work, but not for the reasons you might expect, digging into what the weights and biases are doing is a good way to challenge your assumptions and really expose the full space of possible solutions. By the way, the actual function here is a little cumbersome to write down, don't you think? So let me show you a more notationally compact way that these connections are represented. This is how you'd see it if you choose to read up more about neural networks. Organize all of the activations from one layer into a column as a vector. Then organize all of the weight.
And that's where the matrix algebra comes in. So you basically put this as a giant column, 1 0 1 1 1 0, and then the top abbreviation there in the brackets, that signals which is the actual layer. So it's layer 0, and each layer 0 has all these values inside, and then you have the layer 1 in here. This is 0, this is 1, and this one here, this the first one, there it is. This term right here has this giant sigmoid function, and then the weight, this one multiplied by the weight plus this one multiplied by this weight, and so on, plus this times by the weight plus all these weights and bias and the number here plus times weight, and so on, and then you also have the bias at the end.
As a matrix, where each row of that matrix corresponds to the connections between one layer and a particular neuron in the next layer. What that means is that taking the weighted sum of the activations in the first layer, according to these weights, corresponds to one of the terms in the matrix vector product of everything we have on the left here.
Yeah, so basically this whole thing right here, this multiplied by all these, this summation right here, can be written as just a giant matrix right here. So the matrix, this part right here, plus, this one, the first term, the second weight, this third weight, so 1, 2, 3, 4, all the way down. Those get added in a matrix right here, and these are all the weights associated for this one here. This one, and then this one, and then this one. I think this is W01. Never mind. This is all the weights from here. W00 means this weight goes to the 0, this part right here, and then you have 01. Which is, I think I'm just rethink this one again. 01. No, this is 00 is this weight right here. Yeah, no, so I was doing it right. And then the next one would be 01. So you'll have it from here. This one here, 01 here. So they have it written in the other order. So this 0 goes in the front. So this one 01. 02, 03, 04, and there's a 01, 02, 03. These are all the weights in between here. And then you multiply by this entire column right here. So your matrix times by this vector, and what you end up having is, let's go back.
Terms in the matrix.
Yeah. So this matrix, writing it like this just means this exact same thing here. So this part right here, W00 is this line right here. So what I actually wanted to do was, next time I'll set up my laptop so I could write using my pen right here. But what we could do is put this right here. Yeah, I'm gonna screenshot this, and I'll put in a OneNote right here. I'll change. Actually, I think we have this part right here. I'm just gonna put in a new page quickly. I think I have a bunch of stuff here. 1 second. Math QA. Okay, I think I have it right here. General, I'll put it right like this, just so I could write. So I was trying to figure out a way to connect my my tablet where I could write on. So I'm gonna draw. Let's draw it in red. Yeah, so basically this part right here. Okay, got it. Try laser point. Interesting. So this right here. This is W00. Yeah, then like they didn't write it. So now my computer's frozen. All right, guys. Oh no, it's working. Okay, let's go back here. Is it undo? So this is W00. W0 and 0. So this is the weight of the 0 and 0, and then the weight of the next one is right here. This is W01. And so on. So that's this part right here. And these two parts right there. And that's the same thing as having this weight times, plus. So that weight times it by this number. That's this right here. Plus, now you have the circle part right here. Times it by this number right here. Yeah, this is W01 times 10, this one. And then this just basically means if you multiply it all out, this right here, 10, and then this one multiplied by this, plus this multiplied by this. So in other words, you're writing this whole summation as this part right here, as this, and then you also have to add the bias at the end. All right, so that's that. Okay, let's play it more.
In the first layer according to these weights.
And then you do the same thing for every single one here. So all these and these all have this specific weights aiming at this one. Then this one has specific weights aiming at this one.
Corresponds to one of the terms in the matrix vector product of everything we have on the left here. By the way, so much of machine learning just comes down to having a good grasp of linear algebra. So for any of you who want a nice visual understanding for matrices and what matrix vector multiplication means, take a look at the series I did on linear algebra, especially chapter 3.
Yeah, so I'll eventually do a bunch of videos on linear algebra. That's the one I like doing, but I found it a bit too easy. Like it's just like it's basically everything you've learned and then just put it into a giant matrix. Do it all at once. But I like the nitty-gritty inside here, the stuff here. But I will get to linear algebra.
Back to our expression. Instead of talking about adding the bias to each one of these values independently, we represent it by organizing all those biases into a vector and adding the entire vector to the previous matrix vector product.
Yeah, so again, the whole idea of matrices right here, you can compact all this putting into this as opposed to writing this for every single one of these, like this giant summation. So you could just represent this giant summation as a simple matrix right here that's compact and set up like here.
Left. Then as a final step, I'll wrap a sigmoid around the outside here. And what that's supposed to represent is that you're going to apply the sigmoid function to each specific component of the resulting vector inside. So,
and again, sigmoid just puts it between 0 and 1. So that function is literally just to put it as 0 and 1. So whatever the number you get.
Once you write down this weight matrix and these vectors as their own symbols, you can communicate the full transition of activations from one layer to the next in an extremely tight and neat little
Okay, well, I'm getting a bunch of messages. Alright, I'm getting a message about the, I'm getting a message about that part 34 video I made. We'll get to that, but it's, we'll get to that in a bit. Actually, we'll get that right now, because if we're on these neural networks. Part 34, and, whoops, I don't know why it's going to this one. Okay, just go to the YouTube one. Okay. Yeah, I'm getting messages right now about the part 34. There's a mystery object right here. If you haven't seen my 9/11 Truth Part 34. Hello all, Eddie and guess. Hello all, respect from the Highlands of Scotland. Let's go. And let's go back here. I mean, where's the mystery object? Yeah, this one right here. So there's a mystery object on this roof. So just before the second quote plane comes in, let's play this. Yeah, right here, mystery object right here. There's also a helicopter there flying by, But there's also a mystery object. Look at this right here. I have a 10x speed, but you see this thing on a roof start moving, and it's pretty big to be seen from this far away. So this thing starts moving. It's like a car or something, and then it stops. Stops right there, and it's 20x speed, so it's still a decent distance, but like a few minutes later. And yeah, literally just maybe a minute or two. Yeah, not that long after. It was like a few seconds. So just literally a minute later, this comes in. And also you're going to see the electromagnetic interference right here. Yeah, see that glitch? There's the glitch. See that glitch right there? There's another glitch just as it comes in. But also this mystery object. Like, what in the world's going on with this mystery object? Alright. And like, the only way I spotted this mystery object is playing it at like 100x speed. I just see this random thing moving. There's nothing else moving. And all of a sudden, well, you have the typical helicopter flying around like that. And then you have this thing moving. What in the world's that? So if you know what that mystery object is, or if that building is, let me know, and so on. That's a epic find right there. All right, so that's that. Let's go back into the neural networks. So, and again, this is the whole idea of Matrix 1. You could put this now, compact it into a tiny little term right here. So A1 equals this whole thing. So in other words, this layer, this column, layer 1, like that, can be written as a matrix by just bolding this. There's sigma times it to compress it. So then you have the weighted, this is the weights matrix, times it by the first column as a vector, and then plus the other weight. So you can literally write this whole thing as that.
Expression. And this makes the relevant code both a lot simpler and a lot faster, since many libraries optimize the heck out of matrix multiplication.
Okay, yeah, so anyways, there's a bunch of matrices right here, so define this a bunch of stuff right here, yada yada, initialize weights and biases, return the output for neural network for n vector a blah blah. Anyways, so you write this a equals sigmoid np, anyways, that's just coding for when you put that in the computer.
Remember how earlier I said these neurons are simply things that hold numbers? Well, of course, the specific numbers that they hold depends on the image you feed in. So it's actually more accurate to think of each neuron as a function, one that takes in the outputs of all the neurons in the previous layer and spits out a number between 0 and 1. Really, the entire network is just a function.
Yes, so anyways, the numbers are just functions based on whatever image you're giving it to. So yeah, it is just a giant function that you're getting it. Yeah, so the network is a function.
One that takes in 784 numbers as an input and spits out 10 numbers as an output.
Yeah. So that's the whole idea is you put this into a bunch of digits. So this image right here, put that into 784 pixels or numbers. So that you take all the pixels, put in the 784 numbers that assign it from 0 to 1 or on how dark the brightness is on each spot, and then assign, and then you throw it into a bunch of stuff, and then you get 10 numbers. So you go from 784 to 10.
It's an absurdly complicated function, one that involves 13,000 parameters in the forms of these weights and biases that pick up on certain patterns, and which involves iterating many matrix vector products and the sigmoid squishification function. But it's just a function nonetheless. And in a way, it's kind of reassuring that it looks complicated. I mean, if it were any simpler, what hope would we have that it could take on the challenge of recognizing digits? And how does it take on that challenge? How does this network learn the appropriate weights and biases just by looking at data? Well, that's what I'll show in the next video. And I'll also dig a little more into what this particular network we're seeing is really doing.
Yeah, and the whole idea about learning, I'll watch learning one soon, because we have like 50 minutes left, so decent time. The part of the learning is because like you could put a, let's say, number 1, but you could put it in many different forms. So if you haven't have it trained to recognize all different values, it's only going to assign 1 if it's like a perfect in line with all the bright spots of a number 1. But if you want a bunch of different ones, if you have a 1 at an angle, if you have one at 1 with missing the bottom part, 1 with the like sometimes people just have a 1, it's a vertical line. Sometimes you have the whole shape like that. Anyways, yeah, some of them have without the bottom part like this. So the thing is, you adjust the weight so that it's able to recognize a bigger field of numbers there. Jeff Stewart, bodacious, let's go.
Now is the point I suppose I should say subscribe to stay notified about when that video or any new videos come out. But realistically, most of you don't actually receive notifications learning, and who currently... One thing I think we should quickly bring up is this sigmoid function. As I understand it, early networks use this to squish the relevant weighted sum into that interval between 0 and 1, you know, kind of motivated by this biological analogy of neurons either being inactive or active.
Exactly.
But relatively few
Yeah, I don't know what's going on here. Oh, someone's talking. I think he's
Modern
talking to a
networks
person.
actually use sigmoid anymore.
Yeah.
That's kind of old school, right?
Yeah, or rather, ReLU seems to be much easier to train.
And ReLU stands for rectified linear unit.
Yes, it's this kind of function where you're just taking a max of 0 and A, where A is given by what you were explaining in the video. And what this was sort of motivated from, I think, was partially by a biological analogy with how neurons would either be activated or not. And so if it passes a certain threshold, it would be the identity function, but if it did not, then it would just not be activated, so it'd be 0. So it's kind of a simplification. Using sigmoids didn't help training, or it was very difficult to train at some point, and people just tried ReLU, and it happened to work very well for these incredibly deep neural networks.
All right, thank you, Alicia.
All right, yeah. So apparently, yeah, this was the old one there, and now instead of using that, they just have basically this ReLU setup here, where you have a bunch of it goes to 0. Anything below this threshold is a 0. Anything above it, you consider it as active, and that value is whatever the number was. So if you have a number 3, it becomes 3. If you have a number 4, it becomes 4. As opposed to squishing it to a number between 0 and 1. You don't squish it anymore. Now you just say if it's above 10, or I mean, if it's above 10, you'll just call it it's on. Or no, I think you already include the bias there. So if it's above 10, it will be it would sign it up as that's the starting point of 0. So if it's above your bias, then you start over from that point. So you have, if you have a 2, you get a 2, a 3, and 3, and then anything below inactive. Anyways, so that's this part. Now we're gonna go to the learning one. How does it learn? Okay, so now we'll go gradient descent. How neural networks learn.
Last video, I laid out the structure of a neural network. I'll give a quick recap here, just so that it's fresh in our minds, and then I have 2 main goals for this video. The first is to introduce the idea of gradient descent, which underlies not only how neural networks learn.
And also what I'm going to do is, let's go, what is a neural network? I'm going to go right here, copy this. I'm going to summarize this as well in Leo. Again, throw everything in in Leo, because in Leo is trying to build up a giant database for just public data for the in Leo AI that they're working on. And again, it's all in the Hive blockchain, using the AI agent right here. Summarize this video. The data uses the transcript, summarizes, put on the AI, on the Hive blockchain, and then you have public data that you could access with any AI and so on. So basically, this is the democratization of or democratization of data and AI, as opposed to the black box that ChatGPT and so on use. So it's going to summarize it soon. This is the previous summary. Let's summarize how this neural network is, and it will show up soon. Okay, so that's that. Let's continue further in here. Actually, I think you could just do it inside this chat thingy. Yeah, next time I'll just put it right here inside here. So I'll do that and we'll just summarize, or I'll do it for another time. But anyways, let's continue further. And if there's any other questions, let me know, guys, because we have we have about 46 minutes, 45 minutes left, and so on. And let's see if it shows up now. Mark as red, refresh. This is AI summaries bot, and let's go back here. So how does it learn now?
But how a lot of other machine learning works as well. Then after that, we're going to dig in a little more to how this particular network performs and what those hidden layers of neurons end up actually looking for. As a reminder, our goal here is the classic example of handwritten digit recognition, the hello world of neural networks. These digits are rendered on a 28 by 28 pixel grid.
Actually, before we get further into this, I wanna while we're working on this, because I made the other one before. Let's go to the Jeremy Reese. So for those that were joined earlier, I made the AI video, this one right here, about that disinfo agent Jeremy Reese. I want to make a different one. I didn't like the format, because I set it to I made it to tailor to conspiracy theorists. I want to make it tailored to normal people. I mean, just normies. Let's go to, where did I go to the text bin? God, the paste bin is gone. Let's go to paste bin. Paste bin, alien scientist. Okay, this is the one I wanted. and put that here. Oh no, so it was shared. Okay. Okay, there's the paste bin. Okay, so what I want to do is I'm gonna copy this again. I want to change how it looks like. I'm gonna go create a new. Or maybe I could see if I can modify this. Is there a way to modify it? Just 1 second. We're dealing with AI, and it also has an outline too. Unbelievable. Oh no, outline. Oh, never mind. Just says 00. But it also put timestamps and so on. So like AI is just taking over everything. Okay. Let's go usage. Workspace. Where's my thingy? I just want to see the history of the stuff I made. Like, what is going on here? Usage. Where's my history? Okay. Downloadable. These are the ones I made before, but I just want to modify this. Is there anything I can modify? Okay, so there's literally nothing I could do here. Your public videos. Available to any anonymous user. Okay, edit right here. Okay, this is what. Okay, this it is. Edit. Let's see if I can edit. Edit. Music settings. Is there a way to edit master volume characters? You could add his middle-aged British voice with a charming. Okay, so you can modify it and so on. This is amazing stuff here. I want to see what else we could do with this AI stuff here. Outline. Let me know what I should add to this guy, and then we'll have it running in the background until we figure it out. And you can add characters. Add. Okay. Middle-aged voices. Okay. No, we don't add characters. Cancel. Okay, so this is a discard changes. I'm just gonna go create a new, and then we'll figure out how you could change stuff later. What is this one? I'm late, bummer. Okay, Roy Emotion. You're just in time. I'm making a public safety announcement about Jeremy Reese. I made one earlier, and we'll make one right now again. And let's see how it works. See if a different one. The other one, I didn't like how it looked too laid back. I made it for conspiracy theorists. I'll make another one. Okay, so anyways, it's analyzed. We'll let you know when it's ready to go. Move it over here. So what I'll do as well is I'm going to go to the washroom quickly. So I'm going to go to the washroom. I'll play the current one we have. So this is the... Okay, it's making it right here. So this is a public safety announcement. Okay, this one, we'll go back to while we're waiting. This is just so bad. Where's my videos? How do I just go to media library? Just go to it. Okay, I can't open. Okay, there it is. My goodness. Okay, it doesn't even do that. In video AI. My goodness. Okay. So we'll play this while I go to the washroom. For those who haven't seen it. Okay, where... So what is this, the worst interface? It's like they made this interface with AI. No one even knows what's going on. Okay, that's loading. Generate okay, we'll play this one right here. This is make it big screen. Can't even make it just normal screen. Okay, I can't do this. It's just so painful. Alright, so, okay, so play this. I'm gonna go to the washroom and we'll play this.
I'm sure you've heard the news. Jeremy Reese, or alien scientist, is not who he claims to be. Here's why you should be concerned. Jeremy Reese has a troubling history. Allegedly, he chased his then-girlfriend with a machete in 2015. More recently, he's been accused of beating his then-wife and is currently in a custody battle, but it doesn't stop there. Jeremy Reese spreads dangerous lies about 9/11s, pushing the thermite theory to cover up the use of directed free energy technology. This disinformation campaign raises serious concerns. Some even speculate that intelligence agencies may be recruiting criminals like Reese for their deceptive agendas. Your safety and the truth are at stake. Always critically evaluate the information you come across. Stay informed, stay safe. Beware of Jeremy Reese and his dangerous lies.
Oh, we are back. Okay, how's that video, guys? Let me increase this. Set, I'll mute this. Alright, yeah, I'm just increasing my my desk. My standing is manual, and I gotta get an automatic one. But it's pretty good anyways, so I don't want to... I basically sit and stand like an hour at a time. Alright. So we are good to go. So Gary Jackson says at least AI will admit a 767 commercial passenger plane cannot survive traveling at nearly 600 miles an hour at 1,000 foot elevation. Yeah, definitely. And I also have... so I made one right here. Pilot training impossible is nothing. I made one for the Pentagon plane right here. Make one on Ashton Forbes. Lasso MES dropped some info on last post. You may want to look at on Calamity Forbes. Interesting. Lasso MES. What's last? I'm not sure what you mean. Oh, your last post, or yours or mine. Anyways, let's play this one right here. This pilot training possible is nothing. Made a commercial.
Ready to defy gravity? Let's make the impossible. Ready.
Look how cool this one is. Like it's flying at sea level.
Defy gravity? Let's make the impossible possible. Our pilot training program transforms the extraordinary into achievable. Imagine flying a colossal commercial jet at 460 knots, ground level, amidst steel poles and generators. Wing and ground effect? Triple air density? No problem. Pushing 100 knots past VMO and 165 knots past VA? Child's play. With us, impossible is nothing. Ready to master the skies? Step into the cockpit and soar with confidence.
Yeah, that's it was for the Pentagon one. If you haven't seen the Pentagon one, impossible's nothing. I made a impossible's nothing right here. Nothing. Okay. No, this is different. Okay, this is. I gotta find that. Where did it go? Okay, impossible. No planes. Not kidding. I want to get to the impossible's nothing one. Where did it go? Okay, this is a live stream. This one right here, yeah. So here's the photo of that commercial. So 530 miles an hour, a thin aluminum plane struck 5 light bulbs and a generator. Wing and ground effect. Basically, when it's lower to the ground, the pressure's higher, and there's going to be yeah, more drag and so on. No, I mean less drag. It's going to be less drag. And what is that? Let's see, wing and ground effect. And there's also a bigger cushion at the bottom, so you're not going to be... It's going to be a higher pressure pushing you up. Yeah, so you have a higher lift, so it's going to be harder to maintain like flight at the bottom there. Wing ground effect, air density, three times thicker, 116 miles per hour above VMO, or max operating velocity, 190 degrees above max VA. This is I think that was maneuverability, that's like the speed that for doing maneuvers. And this one just a normal operating one, and then also Nafa Al Hazmi's driver's license quote found. All right, and this is the impossible's nothing. So this is how this. Okay, there it is. And again, this is the exact mainstream narrative. Okay, guys, I'm not exaggerating anything. This is the exact mainstream narrative. Everything here is just absolutely impossible. But impossible is nothing according to Muhammad Atta and his gang. Going back here, you could add Roadie to Motion. You could send me a link. Where am I going on the thingy? You said you had something here in the post. Did you message me here? Okay, this one here. But there's the one that you sent earlier, which is absolutely wild. The one that this person was talking about. Where is it? Like, I don't know where. Okay, this part right here. Yeah, this part right here. No, this part right here. I just hate Twitter. I just hate it. Okay. Ashton Cousins was CIA Director James Clapper. Yeah, so Ashton's cousin was James Clapper was literally his cousin. So where do we get this info from? Let's go. Okay. Oh, name Nathaniel L. Forbes. So where's Twitter at Nathaniel Forbes at Forbes Calamity? Where's James Clapper? No way. His cousin was CIA Director James Clapper. This is Nathaniel Forbes. And apparently they dealt with, grew up in Malaysia. His father trains crisis management teams for international airplanes and banks, like, say, Malaysian Airlines, helping manage one particular Boeing 777-200ER that went missing in 2014. Yeah, this is, well, let's see right here. I tagged you twice. Where are we tagging in? There's a bunch here. There's Nathaniel. I posted 2 screenshots. Calamity prevention, April 14, 2014. Links are dead for me, but what is very interesting is the dates of last posts coincided. Okay, so that's that. Yeah, so we'll have to deep dive into this guy's. Other user has a lot of gamers and corn groups. Okay, interesting. Ashton's a huge gamer. All right, so that's that. Okay, looking at it now. Anyways, yeah, that's wild stuff. I would not be surprised. Well, that makes more sense then. Yeah, that makes pretty much sense. Okay, I'm gonna go. Okay, generate media. I'll do 30 seconds. Yeah, I'll do 30 seconds, not 1 minute. We'll do general public. And yeah, or concerned citizens or general public. No, I think general public, and then YouTube. Yeah, so it'd be YouTube platform or parents or concerned citizens. I'm gonna do concerned citizens. Yeah, I mean general public, and it's 30 seconds. Let's play this. Okay, so it's creating it. Let's see if there's a preview of it. So it's creating the one I wanted to. The other one I didn't like. It was too casual. So let's see if it works. Okay, so this is gonna be absolutely epic. This one here. We'll have to make one for Jimmy Reese. Actually, rotary motion. Rotary. Give me a description. The AI for Ashton. Yeah. So basically, give me a description. I'll copy and paste it there, just because I don't want to do too much stuff. Anyways, and then we'll continue on. So also here's the. I think I just made another. Let's refresh this. I just made another one here. I thought I just did it. Okay. So, okay, this one here, did it make it? Summarize. Oh, this video's already been summarized. Epic. Okay, so no wonder. Okay, so this one's already summarized. Yeah, someone else used it already. So this guy already used it. So I'll upvote his post. And I will, this is 2 months ago. And I will rethread this one here. Because he already summarized as epic stuff, so he already beat me to the game. So I'll go old this. So surprising power of neural networks. Based on an attached transcript, we can summarize the key points about neural networks as follows. Remarkable ability of the brain, etc. Layered structure and its potential, mechanics of neural networks, complexity of neural networks, and so on. Yeah, so that's pretty cool. So I'm going to go back here, guys, and Rory, give me a description. I'll throw it to the AI, because it takes a while to make. So 17% right here. And I want to see, hopefully it makes it like an actual, like a news story. That's what I kind of want. Like a general public, be aware of this Jeremy Reese covering up directed energy weapons and other stuff like that. Anyways, continue further. I'm going to play this. So for those who were watching, yeah, so we went to the neural networks, just basically putting it into a giant matrix. And now we'll see, how does it learn?
In our minds, and then I have 2 of a neural. Last video, I laid out the structure of a neural network. I'll give a quick recap here, just so that it's fresh in our minds, and then I have 2 main goals for this video. The first is to introduce the idea of gradient descent, which underlies not only how neural networks learn, but how a lot of other machine learning works as well. Then after that, we're going to dig in a little more to how this particular network performs, and what those hidden layers of neurons end up actually looking for. As a reminder, our goal here is the classic example of handwritten digit recognition, the hello world of neural networks. These digits are rendered on a 28 by 28 pixel grid, each pixel with some grayscale value between 0 and 1. Those are what determine the activations of 784 neurons in the input layer of the network. And then the activation for each neuron in the following layers is based on a weighted sum of all the activations in the previous layer plus some special number called a bias. Then you compose that sum with some other function, like the sigmoid squishification or a ReLU, the way that I walked through last video. In total, given the somewhat arbitrary choice of 2 hidden layers here with 16 neurons each, the network has about 13,000 weights and biases that we can adjust. And it's these values that determine what exactly the network, actually does. Then what we mean when we say that this network classifies a given digit is that the brightest of those 10 neurons in the final layer corresponds to that digit. And remember, the motivation that we had in mind here for the layered...
Okay, let's see. Yeah. Anyways, go back here. So for those to quickly recap, just to recognize a digit, using 784 pixels takes 13,002 data points, or just a neuron plus weights. So it's
Work classifies a given digit.
all it does lights up. These are small sections. Put the small sections in the bigger section, and these bigger sections correspond to the numbers.
The brightest of those 10 neurons in the final.
And also, Rodin Motion says, Ashton Forbes, citizen journalist, IT professional looking into Malaysian MH370 going missing and trying to connect 2 fake videos to the disappearance. And does Ashton Forbes have connections to 3-letter agencies? Interesting. So you wanted like a question there. Yeah, we'll do that as well. All right, this one's done, I think. Let's play this one, and then we'll go back into the neural networks. We have 29 minutes. Hopefully, we can get some of the more of the learning how it works.
Important safety alert. Jeremy Rees, known online as Alien Scientist, has a troubling history. Allegations include chasing a girlfriend with a machete and beating his wife. Now he's spreading dangerous misinformation about 9/11s, pushing thermite, lies to cover up the use of directed free energy technology.
This is good.
This raises serious concerns about the manipulation of public information. Stay informed. Stay safe.
All right. This one's pretty good. This other one adds more detail. This one is just so good. Okay, I'm gonna download this. All right, this is so good. The news. All right. Let's play this one. I like this one. Okay, this one's probably my number one. Okay, so that was just absolutely wild. Okay, let's go back to neural networks. Okay, it's taking a while to load. While we're waiting, Josh, what the F? Yeah, how good is that one? He's a conspiracy theories about thermite. It's covering up directed free energy technology. Yeah, that's the thing. My dream is to have, like, you go into the news and it's like just commonplace that conspiracy is the name of the game. This one is Jimmy Reese. This is 2.0. Okay, and then this one goes to here. So we made it this one. Okay, I'll send this to the group as well. Okay. Okay, I'll go here and I'll say PSA 2. This is the previous one was a bit yeah, it was pretty it had more detail, but this one is just this one is just absolutely hilarious. This one is my absolute favorite. All right, let's go. Oh, it used a second. No, cancel this one. It changed the URL. No, I want the same URL. I want to rename. Don't copy. Okay, I'm gonna change this into 1.0. And then this one goes to here. Okay, this one's 2.0. Alright, so I'm gonna send this one to the group we have, the Avengers. This one is... Okay, this one's absolutely hilarious. The other one I did like how there's a bit better footage. But this one, the comedy of this one is just hilarious.
Important safety alert. Jeremy Rees, known online as Alien Scientist.
Wait, I have it too fast. I'll play it again, bigger screen. Normal. Up volume.
Important safety alert. Jeremy Rees, known online as Alien Scientist, has a troubling history. Allegations include chasing a girlfriend with a machete and beating his wife. Now he's spreading dangerous misinformation about 9/11s, pushing thermite, lies to cover up the use of directed free energy technology. This raises serious concerns about the manipulation of public information. Stay informed. Stay safe.
Alright. That's pretty good, but why is he wearing a tinfoil hat there? I wanna see if I can edit this one. Okay, anyways, so that's epic stuff. We'll keep those. Okay, and now we can do the other one. For Mr. I'm gonna go paste bin as well. Background towers. Okay, I'm gonna go right here. Paste bin. I'm gonna paste your. Whoops, that was that thingy. I'm gonna go agencies. Okay, and I'll call this one. I'll put a paste bin. And I asked the people in Hive to make one on the Hive blockchain. Rotary Motion, Ashton Forbes. Yeah, Ashton Forbes, an agent. Okay, so it's, just put that there so I have it there because I'll have a link to it. And let's go back here. Create new. Okay. Alright, so we create new Ashton Forbes citizen journalist. Okay, Malaysia. Okay, and then generate video. See this one here should be okay. And let's go back into the gradient descent. Well, we'll wait for this one. And let's go back here. It should be there still. Okay, analyzed. It shouldn't take too long. Thinking. Search it. Search Ashton Forbes MH370 videos. A whole bunch of stuff on it. That's good. Okay, I'll move this. Let's leave it like that. Okay, let's play this.
And a layer corresponds to that digit. And remember, the motivation that we had in mind here for the layered structure was that maybe the second layer could pick up on the edges, and the third layer might pick up on patterns like loops and lines, and the last one could just piece together those patterns to recognize digits. So here, we learn how the network learns. What we want is an algorithm where you can show this network a whole bunch of training data, which comes in the form of a bunch of different images of handwritten digits, along with labels for what they're supposed to be, and it'll adjust those 13,000 weights and biases so as to improve its performance on the training data. Hopefully, this layered structure will mean that what it learns generalizes to images beyond that training data. And the way we test that...
Alright, yeah, so this is back to the training one. This is why AI needs like infinite amount of data. So you would give an image and then assign it a number. So this one has to be a 5. And then you would throw this to the AI and see what it gives you. If it gives you something else, then the question is, how do we adjust to make it go closer to this 5 one? And similar here, this is a 5. What's another? This one, yeah. For example, this one's a 1. This one's a 1. This one's at an angle. It's still a 1. So we have to train it so that it gets this. And this is why it needs infinite data. That's why the self-driving cars and need infinite data. So Tesla, all the Tesla vehicles are all sensing all around them and throwing out all that data into AI. So you have like infinite amount of variations of just different objects, and for the AI to recognize all of them. And it's kind of similar to how humans are. The brain develops. You'll have like a baby, literally touching anything, trying to put in the mouth, feel everything up. It's literally feeding its own AI in its brain. it's a natural AI. It's NI. It's a natural intelligence. It's just feeding everything to it. That's why it's like infinite. There's like a long period of before a human actually has like awareness and everything, self-awareness and all that. So the baby just getting all the infinite amount of data and so on, and some of this AI stuff is being trained like that, and yeah. So it's basically and then now we're gonna learn how does it actually backpropagate to correct itself and adjust for future. And also when you do those reCAPTCHA stuff, when you go into trying to log in and it's asking you, are you a human? Like this stuff here, reCAPTCHA. A lot of it's just feeding the AI. So it's like, it's the it's security / feeding AI. So it's like a bit of a cover. It's like this stuff here, crosswalks and all this. So you're literally just using this to prove you're human. Or in other words, probably just a cover to feed the AI. So you have billions of people doing this online, and then it's feeding back into it. So what? In other words, we're doing exactly this part right here. We're doing, this number is a 5. In other words, that fire hydrant is an image. That one contains a fire hydrant, contains a police car or whatnot, a motorcycle, and so on. And then feeds that into the self-driving cars and everything like that, and the big AI stuff. Anyways, continue further.
Is that after you train the network, you show it more labeled data that it's never seen before, and you see how accurately it classifies those new images.
Yeah. And then there's a prediction one there. So which ones, how many it got right, and so on. Yeah. So you first give it the data, and then you train it on data it's never seen before, and then see how accurate it is.
How accurately it classifies those new images.
So in a way, it's a black box, but it's a structured black box where you can tinker values. That's the key part about the neural networks. It's not necessarily a black box in that you don't know what it's doing. You know what it's doing. You know the general of it, but the actual variations and so on, they're deterministic. But the thing is, they're such big data that you really don't care how it's working as long as it's giving you the numbers. And then you have to tinker it when it's not giving you the numbers. And we'll go over the math of it soon.
Fortunately for us, and what makes this such a common example to start with, is that the good people behind the MNIST database have put together a collection of tens of thousands of handwritten digit images, each one labeled with the numbers that they're supposed to be. And as provocative as it is to describe a machine as learning...
Yeah, so and there's already a project with 10,000 different images. So in other words, it's already basically have infinite data for you available. And that's where data is the big part. When you have everything running on AI, you're going to need more and more data. And you need to have that data public. That's where the Hive blockchain is really, really important. All that text is literally on the blockchain. You don't need to go and ask Google or sign a giant contract. For example, I think OpenAI signed contract with Google for ChatGPT. Let's see, Google this one. Let's see, this is right. I think they signed a deal with AP. Okay, so ChatGPT maker OpenAI, they signed a deal with AP to license news stories. So now they sign it so that they could use their news stories and so on. And yeah, so even if they have the news stories, and now they have access to it and so on. So you're literally paying them to use it. Otherwise, they'll say you can't use it publicly. They'll get sued and so on. So it's a centralized company. They'll have to deal with that stuff. But when you're dealing with a Hive blockchain, you have all the data public there. Anyone can use it without asking anybody else. They just go and use it, and make it all open source and so on. So this one again, data. So basically, they made a deal just to use their articles in the AI. So just to pay for the data. Oh, actually no, this one's not making a deal with Google. So OpenAI is against Google. So apparently they're competitors externally at least. All right, let's go further.
Once you actually see how it works,
let's go see back to the AI one. Okay, this one here, make it 1 minute. Aviation enthusiasts, conspiracy theorists, or general public, rotary motion. Which one are we using? We're using aviation enthusiasts. You can do 10 minutes. No way. Generative media. Oh, we'll do this one. Yeah, I shouldn't have picked stock footage. Okay, realistic. I'm gonna go 1 minute. Visual style realistic. YouTube and we'll do that again. Okay, yeah, that's pretty cool. Oh, you have to pay for that. Generative credits. Okay, this one's generative. Proceed with stock media. Okay, you have to use stock media. Oh, come on. Look at you got to pay for this. Again, this is where the money printing productivity comes in. If AI requires money, in other words, there's demand for those dollars. Generative. Oh man, I want to get that, but I don't want to pay. Screw it. Okay, we'll just do stock media. 1 minute. Aviation conspiracy theorists. Aviation enthusiasts. Or conspiracy. Okay, we'll go general public. We'll do it. Yeah, we'll do this aviation enthusiast or general public. Actually, no, we'll do conspiracy theorists. Okay, so basically, he is an intelligence agency guy. Let's play this one here. Okay. So that'd be cool if we had the generative stuff. It's just using stock footage. My goodness. Okay. So, anyways, let's go back here.
It feels a lot less like some crazy sci-fi premise, and a lot more like...
Yeah, so anyway, it's just calculus.
Well, a calculus exercise. I mean, basically it comes down to finding the minimum of a certain function. Remember, conceptually, we're thinking of each neuron as being connected to all of the neurons in the previous layer, and the weights in the weighted sum defining its activation are kind of like the strengths of those connections. And the bias is some indication of whether that neuron tends to be active or inactive. And to start things off, we're just going to initialize all of those weights and biases totally randomly. Needless to say, this network is going to perform pretty horribly on a given training example, since it's just doing something random. For example, you feed in this image of a 3, and the output layer, it just looks like a mess. So what you do is you define a cost function, a way of telling the computer, no, bad computer, that output should have activations which are 0 for most neurons, but 1 for this neuron. What you gave me is utter trash. To say that a little more mathematically, what you do is add up the squares of the differences between each of those trash output activations and the value that you want them to have. And this is what we'll call the cost of a single training example.
Interesting. Okay, so it takes all those values, so randomly it generates the numbers, the values, and it gets all these, and then you square the difference. And one reason when you square different is it makes it much bigger. So if you subtract this and you square, and you also get a positive value. So it becomes positive 0.43 minus 0 is going to be negative 0.43. Square it, and so on. So they have positive value, and it becomes to 0.1863. And then you sum up all of these differences. So the only one that matters is this one here. You wanted a 1. Everything else 0 you want is for the number 3. This is 3, and they call it a cost function. So, and I think you have to adjust it afterwards. So this one here, the difference now. So notice the biggest, those 5.2, but it got a lot of on the 3, so 0.88. So that's a small cost there. But then you add up all these costs, the one that's really, really far off. So you get 3.37. All right.
Notice, this sum is small when the network confidently classifies the image
Yeah, so it's small when it's accurate, and it's way off when it's not accurate.
correctly, but it's large when the network seems like it doesn't really know what it's doing. So then what you do is consider the average cost over all of the tens of thousands of training examples at your disposal.
Interesting. Yeah, so it's random. So you throw all of those 10,000 in there, and you get an average one. That's a interesting thing.
This average cost is our measure for how lousy the network is and how bad the computer should feel. And that's a complicated thing. Remember how
The individually sequenced neurons, so they can pinpoint down to the individual who will receive what data. Interesting. Individually sequenced neurons, so they can pinpoint down.
the network itself was basically a function, one that
Wait up. I'm not sure what you mean, Tammy, but yeah, it's the idea is there. Let's play this video now. Okay, we have the video, guys. We have Ashton Forbes live. So I'll click download. I'm gonna download stock normal. Continue. Okay. Ashton Forbes shocking MH370 investigation, fake videos and secret connections. Okay, this is gonna be good. It's downloading right now. Almost there. Initializing, finalizing your video. Okay, there's the video. Let's play the video. Actually, let's download it first. So I have a disinfo agents other, and I have Ashton Forbes should be in here. Ashton Forbes. I literally have a disinfo agent. Open this in another tab. So for those wondering, I have a whole like file on Ashton Forbes, just straight up disinfo agents. Okay, so we have Ashton Forbes there. And we'll play this video, guys. First time ever. This is from Rotary Motion. Let's play it.
If you love a good mystery but hate half-baked theories, strap in as we dive into the tangled web of MH370's disappearance. Ashton Forbes, an IT pro turned...
Why is he black? Why is Ashton Forbes black? What is going on here? Why is he black? Alright. We got Ashton Forbes. This is the diversity. We got diversity hire. This reminds me of... we'll play it back again, but it reminds me of the Oprah one here. This is the MES. This is the MES and Oprah MES interview. Where's the one that I had an interview with? Judy Wood, I think. I had this one. Oh yeah, this one right here. No, this is way back. I thought where's the photo? Oprah. Judy Wood. I had this one here. Anyways, where's that Oprah one? Oprah. Okay, I gotta find the MES Oprah one. Yeah. Synthetic biology and its inverse relations. Yeah, for sure. Let's go back here. Oprah. Yeah, Netflix. There it is. I know Oprah, Judy Wood, or MES Judy Wood. Where is that photo? My goodness, I gotta find it. I'm gonna have to look for. I'm gonna have to look for this one. Oprah. I can't believe I can't find it. Okay. Okay. Where is it gone, man? Black. Okay, I have to find that one. I made it. I don't know what's going on here. Netflix. Okay, I'm gonna go right here. Okay, so anyways, before we find that, because I made one where it's like me and Judy Wood interview. Anyway, so Netflix is also doing a Diddy. How did he get? How he did it without any help. This is Diddy right there, and so on. I made a bunch of Netflix stuff. Yeah, okay. This okay, this is good enough. Okay, this is Disney, Greta, Disney, and Frank. When Disney makes a movie about Greta Thunberg. All right, let's go. But I gotta find that that other one. All right, anyways, let's play this quickly. We have 9 minutes.
Citizen journalist. If you love a good mystery but hate half-baked theories, strap in as we dive into the tangled web of MH370's disappearance. Ashton Forbes, an IT pro turned citizen journalist, is shaking up the MH370 investigation. 2 videos once dismissed are back in the spotlight, one showing a mysterious object near the doomed flight and the other suggesting a plasma field. Forbes is digging deep, analyzing data leaks and videos with a skeptical eye.
Why is he a woman now? A trans woman now. Wait, go back here, go back.
Leaks and videos with a skeptical eye. Is he onto something real, or just another wild goose chase? Meanwhile, Vincent Line claims the pilot deliberately crashed the plane into a deep-sea hole, but not everyone's buying it. Aviation journalist Jeff Wise urges caution, demanding multidisciplinary evidence before jumping to conclusions. And then there are the wild theories, hush money funding, the Wolf of Wall Street, and time-space manipulation by Lockheed Martin. Oh, and Elon Musk, he's firmly in the no aliens camp. With renewed calls for another search, could Forbes' investigation be the key, or is there something more sinister at play? Stay tuned, this mystery is far from over.
What in the world did I just watch? Alright guys, AI is taking over all entertainment, guys. How do you compete with this? Alright, so there's AI there. I'll send you the... Here's the link, Rudy Motion. You can go and download it and so on. Okay, we'll maybe go to an X and upload it right here. Okay, let's see, let's go to, where's the one that you sent? Okay, I'm gonna share that right now. Okay, and let's go back here. Oh, I'll share this one right here. Cheers. Okay, where do I find that video? Ashton, oh my goodness, I'm going to do this and find it here. Okay, there it is. Oh yeah. AI breaking news, alright. Why is Ashton... Alright, let's do a laughing emoji. We're almost done. Okay. Okay, so anyways, so we got that in. We're just sending it to you. Let's see, AI.
Half-baked theories. Strap in as we dive into the tangled web of MH370's disappearance. Ashton Forbes.
What is Ashton Forbes doing there? He looks like that RDCH guy. Let's see, RDC YouTuber. He looks like this guy, RDC World. Yeah, he literally looks like this guy. That's literally this guy is this guy here. it's like doing a skit of it. Anyways, so that's Ashton Forbes. We are now back into go back here. We have 6 minutes, guys. 6 minutes to get this sorted. And if you have any other questions, so far you have no math questions, only me talking about AI.
It takes in 784 numbers as inputs, the pixel values, and spits out 10 numbers as its output. And in a sense, it's parameterized by all these weights and biases. Well, the cost function is a layer of complexity on top of that. It takes as its input those 13,000 or so weights and biases, and it spits out a single number describing how bad those weights and biases are. And the way it's defined depends on the network's behavior over all the tens of thousands of pieces of training data. That's a lot to think about.
Alright, yeah, so the cost function takes an average of all of the data and how wrong it was, alright?
But just telling the computer what a crappy job it's doing isn't very helpful. You want to tell it how to change those weights and biases so that it gets better. To make it easier, rather than struggling to imagine a function with 13,000 inputs, just imagine a simple function that has one number as an input and one number as an output. How do you find an input that minimizes the value of this function? Calculus students will know that you can sometimes figure out that minimum explicitly, but that's not always feasible for really complicated functions. Certainly not in the 13,000 input version of this situation for our crazy complicated neural network cost function. A more flexible tactic is to start at any old input and figure out which direction you should step to make that output lower. Specifically, if you can figure out the slope of the function where you are, then shift to the left if that slope is positive, and shift the input to the right if that slope is negative. If you do this repeatedly, at each point checking the new slope and taking the appropriate step, you're going to approach some local minimum of the function. And the image you might have in mind here is a ball rolling down a hill. And notice, even for this really simplified single input function, there are many possible valleys that you might land in, depending on which random input you start at. And there's no guarantee that the local minimum you land in is going to be the smallest possible value of the cost function.
Tanner says, "This is great. Best laugh I've had in days. Learned a lot. Not sure how I feel about training the machine, but I prefer to be a stranger." Yeah, you can be a stranger, but you could train the machine on Hive blockchain. It's all public. So the thing is, instead of using black box AI, you can actually use one where you can tinker with, or you can copy and paste, and then once the data is trained, you can literally go and modify it yourself, and eventually you'll have like there'll be like websites and platforms made where you can adjust what you value and what you don't value. For example, you want AI to lower the importance of the mainstream narrative on for example 9/11, and then increase the narrative that you get from my channel, for example, or and also put all of Dr. Jody Wood's book onto the blockchain, onto the just the AI being trained on it, and so on. So imagine the AI takes all the info I've been talking about, and they put that higher than you get the one on Wikipedia. So Wikipedia 9/11 wiki. So basically, when AI it's just taking data and giving you results based on the data. If this is viewed as true, you're gonna get an AI that literally is like absolutely black box that tells you you need increased security and so on, and you need to suppress people's freedom of speech and freedom of, and everything. So in other words, and then the opposite is if you have open source AI on the blockchain, and then nobody can tamper with the data and so on, and what will end up happening is, and then you're gonna have it your own way. So let's say you don't like ChatGPT, you'll use a different one that puts Wikipedia sources for 9/11 or for any specific thing as like the weight you give it is like a 0. So then this is the new conspiracy theory, according to an AI that I'll be using or I'll be running. This would be a conspiracy theory, and then conspiracy reality would be let's go. Yeah. So you go to conspiracy, Dr. Judy Wood's book, or Where the Towers Go. That's the new thingy there. It should be loading up. So Where the Towers Go. This is the so this would be a higher rating. So anyways, this is a giant ball of turning dust. Where's the book? Buy the book. Buy US Canada. I think you could you can buy it on the website or Where the Towers Go. Yeah, you can buy it right here. So Where the Towers Go. That. So again, AI is just instead of making a black box, you can have it so that you can modify every single thing about it and use any data you want, and have the data where you can't change. That's the key thing about the blockchain, Hive blockchain, is you can't change that data. It's always there, and you can't just have it go and modify it. Like for example, you can do on Wikipedia with the whoever's running it. Anyways, we have 1 minute. Let's see how they do this one.
That's going to carry over to our neural network case as well. And I also want you to notice how if you make your step sizes proportional to the slope, then when the slope is flattening out towards the minimum, your steps get smaller and smaller, and that kind of helps you from overshooting. Bumping up the complexity a bit, imagine instead a function with...
So I highly recommend watching this whole series. I'm learning a different perspective from you than many others. Information is important. As I took a few years off, all things computer frustrated with 9/11. It was computer frustrated with 9/11 and such. Yeah, for sure. No worries. But just know I'll be on your side in the tech revolution. I'm on the yeah. So and also yeah, AI is gonna have a bunch of other stuff that the government's gonna require us. It's gonna go in and inspect your entire history and so on, and then make inputs from that. So it's like, so like anyways, be prepared for all this nonsense that's gonna happen. Anyways, going back, I'm gonna fast forward this and it's end the stream in a bit. But the whole idea is you use a cost function and then you modify each of the inputs to minimize the overall cost function, and yeah, to minimize it at each increment. And the whole idea is to minimize that difference between input and output, and it uses just basic calculus. But in this one is the surface is because you're using a whole bunch of data points from all over, so on. And then you would have it again using the matrix, and it will tell you which ones go increase, which one decrease, and so on. And it's if you do want to dive into this, this is pretty epic stuff here. So I'll need to watch this again. It's been a while. Okay. Anyways, so this one here, and then using it with and the key part is getting like billions and billions of images, and then so that you can constantly adjust those values to get it more and more accurate for each thing. So here's for example this puppy. This is not a line. This is a fork, and so on, and to assign different words to different images, and that's where the reCAPTCHA stuff is all about. All right, guys. A closer look at memorization and deep learning. So I'll have to watch this again, and I'll probably watch the other one as well to get it caught up. And yeah, but anyways, guys, that's all for today, guys. It's 2 hours. I just jump in and see what happens. And yeah, thanks for joining Tammy. And yeah, Tammy, so you're on in Leo, and I'll say thanks for joining and have a great day. All right, guys. I will post this right here. And we had one comment on Rumble. Let's go. 0 on the Threadcast on the InLeo. But anyways, if you guys get on InLeo, everything is there. All this text will be there. Right now, all this text just goes to YouTube, and they share, they hide, do whatever they want. And then this all gets fed into the AI. Imagine you put this here where you can access all this stuff too. So you can go and ask it, hey, what was talked about in this YouTube live stream? And so on. So anyways, guys, that's all for today. And I'm going to go and end the stream. And it's in 3, 2, 1, and yes. Alright, guys, ciao, see you next time. And this Saturday I'll probably do it early one, 10 a.m. stream for a couple hours because I have to go to a baby shower later. So anyways, guys, and so I might do it on we'll see. I might do it on Blue Bacon stuff with 9/11 revisionists. We'll have to see what happens. Anyways, guys, see you later and ciao. Tammy, great reason to switch. Yeah, for sure. Because remember, all this data you're giving it all to YouTube and so on. And I'm doing live stream on YouTube again. I guess biggest audience there. Like for example, I put on Threadcast here. I get 0 comments. But anyways, get on there. You get upvote. You get earn crypto. The data is literally ours. It's our data. We can do whatever we want with it, as opposed to YouTube doing whatever they want with it, and so on. Anyways, guys, that's all for today. And